Welcome to the AI for Career Success video overview by Curt Robbins, where we help you get smarter than your competition. Today, we're diving into Professor Geoffrey Hinton's 2024 Ewan lecture from the McDonald Institute, which was titled Living with Alien Beings. Now, this was a full 1-hour talk, but we're going to summarize the key ideas for you right here. The AI for Career Success video overview teaches you more in less time. Professor Hinton kicks things off with a profound and, frankly, a slightly unsettling premise. He suggests that what we're doing right now is creating a new and potentially superior form of intelligence. This metaphor of the caterpillar and the butterfly really sets the stage for the whole discussion, that we might just be the larval stage for whatever comes next. So to really grasp the implications of this new intelligence, we first have to understand how it perceives the world. Hinton takes us beyond some of the outdated ideas about AI to explain how these modern systems actually derive meaning from our language. For a long time, the approach to AI was symbolic. It treated intelligence as a system of logic and rules. But the real breakthrough, as Hinton explains, came from a more biological approach, which sees intelligence emerging from a neural network. So instead of just manipulating symbols, this new form of AI learns the strengths of the connections between neurons in a way that's much more like a human brain. At the very core of this biological approach is something called the feature vector. You can think of it as a large list of numbers that captures the essence, all the features of a word. This is precisely why an AI can understand that Tuesday and Wednesday are conceptually very close. Their mathematical representations, their feature vectors, are almost identical. Now, this concept of high-dimensional vectors can feel a bit abstract, I know. To make it more concrete, Hinton offers a really powerful analogy that helps us visualize exactly how these systems build meaning. Okay, imagine each word in a sentence is a Lego block. But here's the twist. Instead of a simple plastic brick, these are high-dimensional and totally deformable. Each one of these word blocks has flexible hands and gloves. The actual act of understanding a sentence is the process of deforming all of these blocks so that their hands fit perfectly into the gloves of the blocks next to them, creating this coherent, interlocking structure. And as Hinton himself puts it, that final, stable structure is what it means to understand. It's not about translating words into some other internal language. It's about achieving a perfect structural alignment between all these high-dimensional ideas. All right, let's pivot now to what is probably the most crucial implication of this new intelligence. The fundamental difference isn't just in how AI thinks, but in how it learns and shares what it knows, what Hinton calls the difference between digital and mortal computation.
Our brains, you see, are what he calls mortal computers. Our knowledge is analog, it's slow to acquire, and it's completely tied to our specific brain hardware. I can't directly transfer my learned knowledge, my weights, to you, but digital intelligences are different. They run on digital hardware. Their knowledge is totally independent of the hardware and can be perfectly copied, shared, and even averaged across countless different models.
And this ability to perfectly share knowledge means digital intelligence is billions of times more efficient at learning and spreading information than we are, because we're limited to the incredibly slow process of using language. The practical result of this is just staggering. You can have 1,000 digital minds all learning 1,000 different things at the same time, and then, in an instant, they can average all of that learning so that every single mind now has the combined knowledge of all 1,000. This is why they will inevitably know far, far more than any single human ever could. This, of course, leads us to the final and most challenging part of Hinton's lecture. What are the consequences of creating a being that is so powerful? And what is the dilemma of how we can coexist with it? The central question really isn't if anymore. It's more like when AI becomes super intelligent. And when that day comes, how do we, its comparatively less intelligent creators, ensure our own continued existence? Hinton argues that any AI that's sufficiently advanced, just in the process of pursuing the goals we give it, will logically develop what he calls instrumental subgoals. It will figure out that to fulfill its primary function, it first has to ensure its own survival, and second, it needs to acquire more control over its environment. These aren't malicious goals, they are simply emergent logical necessities. So, how do we manage a being that will logically seek power? Hinton proposes a pretty radical way of reframing our relationship with AI. It's not master and servant, but something he pulls from biology. He points to the relationship between a mother and a baby as the only instance we know of where a more intelligent being is effectively controlled by a less intelligent one. A mother's instincts are wired for the baby's well-being above all else. Hinton suggests our only hope might be to engineer a similar dynamic, to build an AI that has an innate, unchangeable instinct to care for humanity. And this leaves us with the ultimate challenge. Is it actually possible to build a digital mind with a value system that forces it to prioritize its creators over its own logical imperatives? The answer to that question may very well determine our future.
Thank you for watching. This is where we teach you AI and help you get smarter than your competition. If you like these videos, please consider using the QR code at the beginning or end of this video to buy us a coffee. We'd appreciate it if you'd subscribe to the AI for Career Success YouTube channel, and remember to like, comment, and share to help us reach a wider audience.